Hello all, and today we shall see how to formulate a problem using the concept of finite element method. And the problem that we will be considering today is a very simple one, that is of a spring. Now this is definitely not the best diagram of the spring that you would be seeing, but still then that would suffice. Let's say that this particular spring is of two ends 1 and 2 and is being acted upon by force F2 on the right hand direction and by force F1 in the left hand direction. Let's further assume that we would adopt a coordinate system, a Cartesian coordinate system, a Cartesian coordinate system in which the horizontal direction is represented, or the horizontal axis represents x and the vertical axis represents y, such that if this is our origin, then on the right hand side it is considered to be positive value and on the left hand side it is considered to be negative value. This is the coordinate system that we will be adopting for this particular problem. Now see, in this case, when we say that it is a spring, then any spring has also got one more thing, and that is stiffness constant K. Let's say that this particular spring is having a stiffness constant K. Now what does a stiffness constant K means? Stiffness constant K means that how much force is required to displace a particular spring through a particular distance. If let's say that if a spring has to be displaced by 1 centimeter, then if it is having a higher stiffness constant, then it would require more force to displace it, whereas if it is having lesser stiffness constant, then with a lesser force we can displace it through that 1 centimeter distance. So stiffness constant measures that how much force is required to displace a particular spring through a specified distance. Now see, when a force F2 is acting on the right hand side direction and a force F1 is acting on the left hand side direction, then after some time what would happen, that it will get stretched by this much distance and the spring would get elongated because of these forces F2 and F1, and this point 2 would now be shifted to this new location, and this point 1 would also be shifted to this new location. So see here, point 2 has see, in comparison to the original point, this point 2 has moved in the right hand direction by value u2. Similarly, point 1 has moved in the left hand direction by a value u1. So applying the concept of this coordinate system, we would consider this u2 to be positive and this u1 to be negative. So in this case the total displacement delta is equal to u2 minus u1, because u2 is considered to be positive here and u1 is considered to be negative here. Okay. Similarly, this force F2 would also be considered as positive as it is acting on the right hand side direction, and since this force F1 is acting on the left hand side direction, so it would be considered negative. Now on this left hand side, see, applying the concept of stiffness constant and that spring, the relationship between the spring stiffness constant, displacement of the spring and the force acting on the spring, we can say that at point 2 it would be, the equation would be F2 equal to stiffness constant K multiplied by u2 minus u1, and on the other end, this one is at point 2. Similarly, at point 1 it would be F1 equal to stiffness constant multiplied by displacement u2 minus u1, but since F1 is negative as it is acting on the left hand direction, so we need to put one minus sign here. So it can be rewritten as F1 equal to minus K into u2 minus u1. So let's say that this is our equation 1 and this is our equation 2. This is for AND 2 and this is for AND 1. So from equation 1 we get F2 equal to K into u2 minus K into u1, and from equation 2 we get F1 equal to minus K u2 plus K u1. If we rearrange the terms, then we can write it as F2 equal to minus K u1 plus K u2. Similarly, F1 equal to plus K u1 minus K u2. So these are the two equations for the forces at the two ends 1 and 2. So if we just write it in a what to say, matrix form, then it would be like, it can be represented like this. There is F2 F1 equal to minus K plus K plus K minus K u2 u1. But since it looks very odd, so let's just rewrite it in a more presentable form, and While rewriting it in a more presentable form, we would ensure one more thing, that it does not deviate from its main concept, and we can still write it as f1 f2. Still write it as means we are still maintaining the physical meaning of the equations, but we are rewriting it in a more presentable manner. K minus K minus K K U1 U2, and that is the total formulation for one dimensional problem. Thank you.